Research shows that more context can actually make your AI agents less intelligent. As the context window grows larger, AI agents start forgetting what they are doing, calling wrong tools, and getting stuck repeating itself. So, what is really happening here? Is it the model getting worse? No. It's the context that you are feeding into the model. So, how do we fix the context? The answer is context engineering, and that is what we'll be learning in this video. We'll take a look at what are the problems that exist with larger context, what is context engineering, how is it different from prompt engineering, and how to context engineer your agents. If you're new to the channel, my name is Nirjari. I'm a software engineer on a journey to learn and grow every single day. If you're on a similar journey, then subscribe to my channel and follow along. So here are the 4 problems that happens with larger context: context poisoning, context distraction, context confusion, and context clash. Let's take a look at each of these in detail. So context poisoning happens when hallucination makes it into the context and is referenced again and again. Let's say an agent invents a fact at turn 4 and by turn 20 it's treating that fact as ground truth. Context distraction happens when the context grows so long that the model over focuses on it and forgets what it learned during the training. Context confusion happens when the model is given multiple competing pieces of information and can't tell which one is relevant. For example, if a job application agent is applying for a Google job and has Amazon's job description in the context, it might get confused and mix the details of both. Context clash happens when there's new information which contradicts with the information that is already present in the context. So let's say your agent fetches some config file at turn 2, then the file changes and it again fetches that same config file at turn 9. Now it has two different versions of the same file and no idea on which one is current. To solve these problems with context, a term was coined which is called context engineering. It is the practice of curating exactly what goes into the model's context window at the time of inference and nothing more. And to be precise, what context really means here, because it's broader than what people really assume. So, context is anything that your model sees. It can be system prompts, tool call definitions, tool call results, memory files, messages, histories, documents, etc. All of it. So now that you know what context engineering is, you might be wondering how is it different from prompt engineering. So prompt engineering is basically writing right instructions that you want to give to LLM, whereas context engineering is choosing the right instructions that you want to send to the LLMs. So in prompt engineering, you are basically controlling by writing, whereas in context engineering, you are controlling by deciding what to include and what to leave out. Karpathy's framing is my favorite, where he says that the job of an agent designer is to pack the context window just right. Now that we know the problem, let's get to the interesting part on how to context engineer and fix the problems with large context. First technique is context offloading. It is the simplest one and the one you should try first. Give the model some space for writing down things outside of the context window. It can be a file, a state field, or any other place where it can write down intermediary findings, dump notes, or progress, which it can pull back later instead of carrying it around forever. Anthropic found that context offloading helped improve the agent's performance by 54%. Next technique is retrieve just in time. The old pattern was you embed your whole corpus up front, then get the top K relevant stuff and put it in the context even before the model starts, which was classic RAG. But the agents change the shape of it. The newer pattern is just in time context, where the agents don't load everything up front. Instead, they go and carry only the lightweight identifiers like file paths, query strings, URLs, and then use tools for getting the content into the context at the moment when they need it. This is similar to how we humans work. We don't really memorize the entire code bases. We just keep a mental index and open the file when we need it. The strongest agents in practice will be actually using hybrid approach, wherein you load small always relevant stuff for speed and let the agent explore autonomously for everything else. Next technique is curate your tool loadout. RAG MCP paper found out that past 30 tools, the tool description started overlapping and models got confused as to which tool to call. Past 100 failure was essentially guaranteed. So you should ideally store all the tool descriptions in a vector database and retrieve only the ones that are relevant per the task in the context. This not only helps with only putting the right information needed in the context but also improves your tool selection accuracy. So the next technique is compaction. When conversation approaches context limit, you summarize it and reinitialize a fresh window with a summary. Claude Code does it automatically. Auto compact fires past 95%. But the hard part here is what you'll actually keep in the context. How Claude Code does it is that it keeps all the unresolved bugs, the architectural decisions and constraints, whereas dropping off any redundant tool outputs. My advice is that you keep your compaction step separate evaluated LLM calls so that you can measure what things it's dropping off that it shouldn't. Lighter weight sibling of compaction is pruning, which is removing any irrelevant data from the context and not really summarizing it. The next and final technique is context isolation or context quarantine. Instead of one agent carrying everything all together, split the work across multiple sub-agents, each with its own clean context window, own instructions and own tools. Is that isolation only works when sub-agents or subtasks are genuinely independent. If your agents need to share a lot of state, then you'll spend more tokens coordinating than you saved. So offload it, retrieve just in time, curate your tool loadout, compact it or isolate it. And if you forget all five, just remember, context is not free. Every token has a cost, not in dollars, in attention. So next time when your agent starts drifting, don't reach out for fixing the prompt first. Open the actual context that you are sending and read it top to bottom like the model does. And ask the only question that matters. Is every token in here earning its keep? If it isn't, then you've got 5 ways now to fix it. I hope you got to learn something from this video. If you want me to go deep on any of these 5 techniques, tell me which in the comment section. See you in the next one.